Well, good afternoon, Chem 1. It's May the 7th, a Thursday. I know that the PowerPoint goes over acids and bases a little bit, but I wanted to touch on them just a little bit to give you a little better information, I think, hopefully to help you out quite a bit. So we're going to talk about acids and bases. And what you want to do is just, what are some acids and bases in your house? Before we do that, maybe I'll look at some of the properties. Now, acids have a sour taste. Now, no, I don't want you to go take a corrosive acid and taste it, but if you've ever had a sour candy where they put citric acid or something like that on, it has that real sour taste. Bases, on the other hand, have a bitter taste. Bases are also kind of slimy, slippery. Soap is an example. Soaps are made from bases, and you know that they're kind of slimy and slippery. Both acids and bases, that's what this category means, can be corrosive. And what that means, they can damage the skin. And some of them can burn deep enough even to damage tissues. Acids and bases also will affect indicators, so both of them will have an effect on indicators. Now, what's that? Well, maybe in junior high or elementary, your teacher made some cabbage, boiled some cabbage. Usually it's a red cabbage. And in the presence of a base, it turned blue. In the presence of an acid, it turned red. Well, in my shelf in my room, I probably have at least a dozen, 15 different kinds of indicators. If you end up in Chem 2 next year, we're going to do some experiments with acids and bases, and we do different indicators for that. One of the things that I also want to show you a little bit, we'll get to neutralization reaction a little bit later, but acids and bases, we measure those with what's called a pH scale. And pH, if it equals 7, it's a neutral solution. That stands for solution. If the pH is less than 7, it's an acidic solution. And if the pH is greater than 7, it's a basic solution. Okay, so pH is just a way of measuring it. And so some examples of what you have around your home. That's an acid. Vinegar is an acid. If you have any kind of soda in the refrigerator, those are acids. They are carbonated with carbonic acid. CO2 in water gives us carbonic acid. And so that's why they have a sour taste. And you put in sugar to counteract that sourness. That's why there's so many grams of sugar in a serving, or an artificial sweetener in there as well. Bases around the house, baking soda would be an example of a strong base. Bleach would be a base, as would ammonia would be a base. Now, what's a salt? Well, you know salt is sodium chloride. But any acid-base reaction, if I say an acid, and I'm going to get to this in the next video, but I want to show you, base will always produce water and a salt. So if I mix hydrochloric acid, and I'm jumping the gun on the video, sorry about that. This makes water, and the only reason I'm doing this is because you're familiar with sodium chloride. Okay, table salt, and put on your French fries. But so that's just an overview of acids and bases. Acids and bases generally will be conductive electricity. Both of those would do that. So a property of an acid would be turn an indicator, red. A base would turn it blue. But both would have some kind of effect on indicators. So that's it. That's just what I wanted to generally go over. Again, the PowerPoint has some good examples there as well. I think the assignment that was laid out generally for next week is to look around the house and see what you have that are acids and bases. I've kind of gone over a couple with you already. I'm sure you can Google that and come up with some others. I'm not too worried about that right now. Main thing is I want you to know some basic properties of acids and bases, what they have in common, and then some things from a salt as in terms of a neutralization reaction, which I'll do in the next video. So that serves our intro. That's it for now. Bye.